Ever stopped and wondered to yourself, just how hot is the center of the Earth?
Colossal Question.
The center of the Earth is close to 4,000 miles beneath our feet. That's deep. Really deep. If you wanted to tunnel your way down to the center of the Earth, you'd have to dig through the planet's 4 layers: the crust, the mantle, the outer core, and the inner core. The outer layer is the crust, made up of solid rocks and minerals. In all our years digging into the ground, humans have never been able to dig past the crust, even with state-of-the-art equipment. It's a bit like the crust of a pie, a thin, hard outside layer that makes it look solid, even if the insides are gooey. Compared to the other layers of the Earth, the crust is actually quite thin. Under land, it ranges from 19 to over 40 miles thick. But beneath the oceans, the crust can be just 3 miles thick. Considering that the center of the Earth is 4,000 miles down, just a few miles of crust isn't much. Even still, humans have never managed to drill any deeper than 7.6 miles down. That deep? Temperatures are so high, over 350 degrees Fahrenheit, that the drilling equipment breaks down in the unbearable heat. 350 degrees is hot. So hot that humans couldn't survive it. Yet it's not even close to how scorching hot it gets at the center of the Earth. Below the crust is the largest layer, the mantle. It's also mostly solid rocks and minerals, mixed with soft, semi-solid areas of molten magma. The mantle is over 1,800 miles thick and is mostly made up of elements like iron, magnesium, and silicon. Beneath the mantle is the Earth's core, which is split into 2 sections, the outer core and the inner core. The outer core is big, almost 1,400 miles thick, and it's mostly made of liquid iron and nickel. The inner core is incredibly dense. Just like the outer core, it's mostly made of iron and nickel. But unlike the outer core, experts believe it's hard rather than liquid. Okay, so that's all the different layers of the Earth, but how hot does the core actually get? Really, really hot. The edge of the outer core is about 7,000 degrees Fahrenheit, and the inner core is even hotter, over 10,000 degrees Fahrenheit. That's about as hot as the surface of the sun. So next time the sun is beating down on your back on a scorching hot summer day, just remember, it could definitely be worse. Ever since we first landed on the moon, people have had their eye on the next closest target for exploration, Mars. But how realistic is that? Could humans really live on Mars?
Colossal Question.
Space agencies around the globe are hard at work trying to figure out how to put humans on Mars, maybe within our lifetime. How do they plan to do it? The journey to Mars will be long, so the spaceships can't just be bigger, they need to also be much more energy efficient. You see, once the ship leaves Earth's atmosphere, it'll need some sort of propulsion system to blast it all the way to Mars. And Mars is about 200 times farther than the moon. That's not exactly a quick trip. Even with state-of-the-art tech, experts believe the journey could take anywhere between 7 to 9 months. That's what makes fuel efficiency so important when it comes to sending a spaceship to Mars. So, for such a long trip, what kind of energy-efficient fuel might we use? Well, most likely a super hot electrically charged gas called plasma. When harnessed by a special kind of engine, plasma acts kind of like the biggest shock of static electricity you can imagine. Strong enough to blast a massive spaceship into outer space. The special kind of engine is called an ion thruster. They've been used by space agencies for decades to explore deep space, but never on anything close to the scale you'd need to send a large manned ship all the way to Mars. More efficient fuel means you need less of it to make the trip. Less fuel means the astronauts have more room on board for food, water, air, research equipment, and anything else we might need while on Mars. When the spaceship finally arrives, it probably won't land. It's way too big to land safely on the surface. Instead, it'll circle around Mars, acting as a space station. Crews would likely descend in small capsules designed to land on the dusty surface. Once safely on the surface, astronauts would set up and live inside a special pressurized and temperature-controlled tent-like structure called a habitat. Why? Well, Mars's atmosphere is a lot thinner than Earth's. That means there's way less oxygen to breathe. It also means it's a lot colder. Mars is -81 degrees Fahrenheit on average. Not the kind of conditions humans could survive without technology. Humans would need to put together solar panels, harvest water from deep underground, and build big greenhouses full of plants that can survive all the harsh planetary conditions. Some plants would be grown for food, and others would be grown to make oxygen for the astronauts to breathe. Right now, this all might be hypothetical, but expert engineers around the Earth are getting closer and closer to bringing these colossal plans into reality, reworking and perfecting their designs for the ideal mission to Mars. So, yes, humans could one day live on Mars, but who knows when? It could be 300 years from now. It could be 30. If everything works out, it might even be you. Have you ever heard the sad story of Pluto, the poor little dwarf planet that was? For decades, it was considered the farthest, smallest, and coldest planet in the solar system, until it was kicked out of the group. Talk about cold. So what on earth happened? Why isn't Pluto considered a planet anymore?
Colossal question.
Did you know that thousands of years ago, people didn't have every form of entertainment imaginable in front of their eyes at all times? Yup, they had to sit down, relax, and just look up. Sounds boring, right? Maybe at first, but once the sun went down, people started to notice that there were lots of interesting things up in the night sky. Not just pretty little stars, but patterns, colors, and objects of different sizes that seemed to move differently than the rest of the stars blinking in the sky. People started noticing these strange little balls of colorful light. Balls that would ultimately be known as the planets in our solar system. But finding each of the planets in our solar system took some time and some stargazing. Funny enough, Earth wasn't actually the first planet we discovered. We lived here all along, so first we had to look up and discover other planets in the sky before we realized we were on one of them. Ancient Babylonian astronomers ID'd Mercury, Venus, Mars, Jupiter, and Saturn sometime between 3,000 and 4,000 years ago. That's a really long time ago. The idea of the Earth being one of the planets in the solar system dates back to at least ancient Greece around 2,300 years ago. The ancient Greeks called them planetes, which is where we get the word in English. It means wanderers, since the planets forged their own paths through the sky. Over the next 2,000 or so years, humans mostly found the occasional meteor, asteroid, or moon floating around in the solar system. It wasn't until 1781 that the next planet was discovered, Uranus. An astronomer named Sir William Herschel first mistook the seventh planet from the Sun for a comet. Fast forward 65 more years to 1846, and Neptune is officially discovered by Johann Galle, the eighth planet from the Sun. Fun fact, it was actually first spotted by Galileo all the way back in 1612, but he mistook it for a star. Whoops! And finally, of course, there was Pluto. The poor dwarf planet that used to be a planet was discovered in 1930. This gave us a solar system of 9 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and last but not least, Pluto. It was the coldest, furthest, and smallest planet of the group. even smaller than the Earth's moon. Pluto was a fixture in our solar system for more than 70 years, just minding its own business out in the furthest reaches of our solar system, doing its thing. So, what changed? Well, Pluto itself didn't actually change at all. What did change was the actual definition of a planet back in the early 2000s. You see, up to that point, the scientific definition of a planet was surprisingly loose. There was no real criteria to decide what officially made something a planet. Up to that point, astronomers had loosely grouped all the planets together, since they all seemed to move on their own paths through the sky, unlike stars. For a long time, this super loose definition wasn't much of a problem, but that started to change as more and more Pluto-sized planetoids were being discovered. In the past, it would take hundreds, sometimes thousands of years for humans to notice a new planet. But with modern technology, we started finding lots of new things quickly. So quickly that we were forced to ask, should all these new discoveries be considered planets too? After all, they weren't much different from Pluto. And if Pluto was a planet, then without an official definition, they probably should be planets too. So in 2006, some of the top planetary scientists got together to try and define a planet once and for all. They came back with just 3 basic things an object needed in order to be considered a planet. First, it needed to orbit the sun. For Pluto, that's a check. Second, a planet must be large enough so that its own gravity molded it into a spherical shape. Another check for little round Pluto. But the third condition for planethood is where Pluto ran into a problem. A planet must clear the neighborhood of its orbit. In other words, as a planet travels, its gravity should clear the space around it of other objects. Some objects might crash into the surface, others might start orbiting the planet and become moons. Unfortunately for Pluto, it simply isn't even close to big enough to clear everything in its path. So, astronomers decided to officially reclassify the former 9th planet Pluto as a dwarf planet, leaving us with only 8 planets in our solar system. As of 2023, there are just 4 other dwarf planets in addition to Pluto: Ceres, Eris, Haumea, and Makemake. So, why isn't Pluto a planet anymore? At the end of the day, the little planet that could in the far reaches of the solar system simply isn't big enough to be an actual planet, at least not based on the current definition. It might sound cold, but honestly, it's nothing new for that frozen ball of ice. So don't shed too many tears for poor Pluto. I mean, it's floating so far out there, chances are it hasn't even gotten the memo yet. The all-powerful sun. It brings us light, warmth, and without it, there wouldn't be much life on our planet. But have you ever actually wondered what would happen to life on Earth if the sun suddenly burned out?
Colossal Question.
The sun is a star in the center of our solar system that all the planets orbit around. It's because of the sun that life on Earth exists in the first place. Experts have determined that the Earth's distance from the sun is just the right distance for humans to survive. If Earth was a little closer, we'd all be burnt to a crisp. But if it was a wee bit further away, we would all freeze to death. Or, in other words, almost all living things on Earth rely on the sun for survival. So that leaves us with a pretty big burning question to answer. What would happen if the sun suddenly burned out? Well, for starters, it would take over 8 minutes before we'd even notice here on Earth. That's because the sun is so far away that it takes light over 8 minutes to get from the sun to your eyes. But once those last magical minutes passed, it would be absolute, complete darkness. And that goes for the moon, too. You see, moonlight is just sunlight reflecting on the moon. So even if the sun burned out at night, you'd still see the moon suddenly disappear into darkness. We rely on the sun not just for its light, but its warmth too. So if the sun burned out, things wouldn't just get dark, they'd start getting really cold. Within a week, temperatures around the globe would drop to below freezing, kind of like the coldest winter day every single day. Within a year, Earth would drop to over 100 degrees below freezing, which is so cold that no human could survive on the planet's surface. The temperature would keep dropping and dropping and dropping over hundreds and thousands of years until it settled around -400 degrees Fahrenheit. So, next time the sun seems annoying on a sweltering summer day, just remember, it could be a lot worse. It seems like something out of a sci-fi summer blockbuster. The day the sun exploded. But what if it happened for real? What if the sun really exploded?
Colossal Question.
The big, hot, glowing ball of light we call the sun is really a medium-sized star out in space. When a star explodes, we call it a supernova. A supernova is very rare, very bright, and very powerful. If our sun suddenly exploded into a supernova, well, the whole solar system would be destroyed in the blast. The colossal boom would vaporize whichever side of our planet happens to be facing the sun, and the other side wouldn't make it out much better. The temperatures would be about 15 times hotter than the surface of the sun. In other words, if the sun went supernova, the entire planet would be destroyed, and quick. That's the bad news. But there is good news too. Our sun is way too small to ever explode. Only really big stars go supernova, and our sun is considered medium-sized, so that's nice. Sadly, there's more bad news. Our sun may never be a supernova, but that doesn't mean it won't have a destructive death. So, how will our sun die? Well, instead of simply exploding, our sun will actually start to get much bigger, turn red, and become slightly colder but still scorching as it dies off. Astronomers call this kind of star a red giant, and they mean it when they say giant. The sun will get so big that it'll completely eat up Mercury, Venus, and, yep, Earth too. Mars will survive, but become a burning hot desert. Once the sun becomes a big, bulbous, full-sized red giant, it'll start to blow its outer layers off into the solar system. Think of a star kind of like a balloon. A supernova is a bit like popping a balloon, quick and extreme. But our sun's death will be a lot more like air being slowly let out of a balloon. As more and more of the outer layers of the sun are released into space, the star will get smaller and smaller until there's just a white-hot core remaining called a white dwarf. Once our sun hits this stage, it'll only be slightly bigger than the Earth, but about 200,000 times more dense. Mercury, Venus, and Earth will all have been destroyed long ago when the sun was a red giant. But Mars, Jupiter, Saturn, Uranus, and Neptune will keep spinning around the sun. Since white dwarfs are so tiny compared to your average star, they don't give off very much light and continue to slowly get dimmer and colder over billions of years, eventually becoming so dark they give off almost no light at all. So, could our sun ever explode into a supernova? Nope. But its eventual death will still be bad news for everything and everyone on Earth. Lucky for us, that won't happen anytime soon. The death of our sun is expected to happen several trillion years in the future. So, scary? Sort of. But unless you plan on sticking around for the next several trillion years, you don't have to spend too much time worrying about the heat death of the universe. There's plenty of time for you to prepare.